This presentation is a brief overview of nuclear power and why it ought to be considered a valuable, if not irreplaceable, part of the energy solution. To begin, I'd like to simply introduce why responding to climate change is as important as it is. The data suggests that the Earth's temperature has always varied, as well as its CO2 levels. What's concerning, however, is the rapid increase of carbon and other related greenhouse gases since the beginning of the Industrial Revolution. This leads one to believe that human behavior is inevitably at the root cause of this spike. Nuclear power was first discovered by the Hungarian physicist Leo Szilard. In 1933, he developed what would be known as the nuclear chain reaction, where the splitting of a single atom releases neutrons, which react with the available fissile material, leading to many more subsequent reactions, resulting in a high energy output. In 1934, he patented the design alongside Enrico Fermi, and in 1939, just as the rest of the world was beginning its descent into the worst battle it had ever seen, he sent his famous letter to Albert Einstein to initiate what would become the Manhattan Project. Although the 20th century portrayed nuclear power solely as a means of mass destruction, many scientists pushed to harness this technology as a primary energy source. Currently, the main forms of energy production across the globe are derived from coal and oil products. When they're burned, the byproducts are emitted into the atmosphere. Carbon specifically lingers in the atmosphere and in the Earth's natural sinks longer than any other greenhouse gas and is thus the primary culprit behind the Earth's rising temperature. Nuclear energy is generated via nuclear fission, a process where a uranium atom is split, resulting in the release of neutrons. These free neutrons will then interact with the surrounding medium, and if more fissile material is present, some may be absorbed and cause more fissions. Thus, the cycle repeats to give a reaction that is self-sustaining. This is a carbon-free process, as no burning is required, other than for ancillary use such as the mining of uranium, the processing of fuel, system maintenance, and construction of power plants. For standard nuclear power generation, uranium-235 is generally used as nuclear fuel. On a side note, highly enriched uranium or plutonium is required for the weaponization of nuclear power. Therefore, developing such weapons is expensive and technically complex. At the time of this presentation, 3 major nuclear incidents have taken place. The first one was the 3 Mile Island accident, which occurred in 1979. The next and most notable incident was the notorious Chernobyl disaster of 1986, and the most recent one occurred in 2011, when a major tsunami and earthquake struck the coast of Japan, where the Fukushima Daiichi nuclear reactor power plant was relocated. What most people have failed to acknowledge is how relatively mild each of these incidents were. The partial meltdown of reactor number 2 at 3 Mile Island, although costly for the owners, saw no deaths as a result of the accident. Furthermore, of the 2 million people surrounding the area, the average dose of radiation was approximately 1/6 of that which a person receiving a standard chest X-ray would experience. In spite of the serious damage to the reactor, the actual release had negligible effects on the physical health of individuals or the environment. Chernobyl, the worst of the 3, saw a mere 31 directly related deaths. The radiation exposure has led to estimations of how many people would actually die due to both high and low-level exposures across the surrounding regions. The next slide outlines these estimates. Finally, Fukushima was another accident that, although disastrous, resulted in 0 deaths related to nuclear turmoil. However, it has been estimated that approximately 1,000 to 1,600 people died due to evacuation protocols and stress-induced factors. The World Health Organization reported that exposure levels were too low to affect human health for the national population, with the exception of a few communities in close proximity, where the projected number of deaths from low-level exposure was close to 0 and up to 400 in upper estimates. While the compromise of the nuclear power plant had a negligible impact on human health, the actual tsunami and earthquake killed approximately 16,000 people. Here we can see the projections of both the Chernobyl incident and the Fukushima incident. While these projections might seem high, they represent the upper estimates of each study that took place. Furthermore, when we compare these values to the mortality rate due to other energy sources, we can clearly see that nuclear power might not only be the cleanest energy source, but also the safest. Aside from the threat of nuclear disaster, the other concern remains on how we ought to go about disposing nuclear waste products. Rather than dumping it into our water supplies, as most people seem to think, countries such as the US, Finland, and France all have safe and reliable disposal protocols. Once the spent fuel is removed from the reactor, it is stored in concrete and steel pools for cooling. Once it reaches acceptable temperatures, it is transferred to large concrete dry casks that have been reinforced with steel. From here, it can be transported to the low and high level disposal sites. For example, the U.S. nuclear energy industry has safely transported used fuel without any harmful release of radioactivity, injuries, or environmental damage. Since 1970, of the 7,000 shipments of used fuel by the worldwide nuclear industry, No leaks of radioactive material or personal injuries related to radiation exposure have occurred. Furthermore, used fuel has normally only exhausted part of its fuel capacity after 5 years. Some countries, like France, actually reprocess used fuel and extract those parts that are still capable of generating energy. Despite these benefits, many people are still moving away from nuclear power as a primary energy source. This is likely proven to be a battle of not just data and facts, but of policy and public opinion. With the surplus of information we are exposed to today, it seems we are at war with what is true and what is fiction. Nuclear power has proved to be one of the safest and most reliable energy sources available, despite what mainstream media has led us to believe. As of now, it appears to be the only low-carbon technology available to us which is capable of meeting global energy demands. By cooperating among different nations, we have the potential to implement a plan that could aid us in our fight against climate change and present itself as the silver bullet we have been searching for.